All right, so this time we are going to do some mixed practice. All right, so I think we're going to try to do all four of these. So first one, we have 4.22 times 10 to the 15th atoms of uranium to grams. So we're going to start out with our given 4.22 times 10 to the 15th atoms over 1. There we go. All right, so we do our first conversion factor. We put atoms on bottom so that atoms cancels out. Okay, we want to convert that to moles, so we put moles on top. 1 always goes next to moles. The number that goes next to atoms is 6.022 times 10 to the 23rd. Sorry, that's squished. Okay, so now atoms cancels out. We're left with moles. Moles is not where we want to be. We want to be at grams. So we need another conversion factor. Okay, so we put moles on bottom so that moles cancels out. We put grams on top. We put 1 next to moles. Okay, so now next to grams, we put the molar mass of uranium, which just happens to be 238.03 grams per mole. So now moles cancels out. We're left with grams, which is where we want to be. So now we do our math, okay? We do 4.22 times 10 to the 15th multiplied by 238.03. So I'm going to do that real quick. 238.03 times 4.22 times 10 to the 15th. And we get... I'm going to do it up here a little bit because I ran out of room. 1.0045 times 10 to the 18th. And then our number on bottom is 1 times 6.022 times 1. So that's just going to be 6.022 times 10 to the 23rd. And that is going to give us 1.67 times 10 to the negative 6th grams of uranium, and that is our final answer. Okay, and we only have 3 sig figs because our problem only has 3 sig figs, and that's it. All right, next one. We are going to start with our given, as usual, 8.65. I'm going to try to make this a little bit smaller so I can fit it a little bit better. Times 10 to the 25th. Molecules, so particles, over 1. Okay, we do our first conversion factor. This is we put particles on bottom so that it cancels out. We do moles on top. 1 goes next to moles. 6.022 times 10 to the 23rd goes on top. Molecules cancels out. We're left with moles. That is not where we want to be, so we do another one. Moles on bottom. We want to be at liters, so we put liters on top. 1 goes next to moles. The number that goes in front of liters is 22.4. Okay, so then we do our 8.65 times 10 to the 25th times 22.4. We get 1.9376 times 10 to the 27th divided by 6.022 times 10 to the 23rd. Oh, and I forgot moles cancels out, and we're left with liters, which is where we want to be. So then we do our math, and we get 3,220 liters. And that is our final answer. All right, next one. 84.57 grams over 1. We do our first conversion factor. We need grams on bottom, moles on top. 1 goes next to moles. The molar mass of Fe2O3 is 159.7. Grams cancels out. We're left with moles, which is not where we want to be. We want to be at molecules, so we need another conversion factor. Moles on bottom, particles on top. 1 next to mole. Oh, and I don't have enough room there, so I'm just going to do 6.022, and that's supposed to be times 10 to the 23rd. Moles cancels out. We're left with particles, which is where we want to be. So now we do our math. 84.57 times 6.022 times 10 to the 23rd, and we get 5.093 times 10 to the 25th divided by 159.7. And when we do that, we get 3.189, 4 sig figs this time, because we have 4 sig figs here, times 10 to the 23rd particles. Oh, shoot. Sorry about that. I don't know how that happened. All right. That's our final answer. Now, last one. We have 14.44 grams over, oh, shoot. Sorry. Over 1. Do our first conversion factor. We have grams on bottom, moles on top, 1 next to moles, and the molar mass of CH4 is 16.05. Grams cancels out. We're left with moles. That is not where we want to be. We want to be at liters, so we do another conversion factor. Moles on bottom, liters on top, 1 next to mole, 22.4. 4, there we go, next to liters. Moles cancels out. We are left with liters, which is where we want to be. So now we do our math. 14.44 times 22.4. We get 323.456 divided by 16.05. And we get a final answer of 20.15 liters. And that is our mixed mole practice.